Hello and welcome to the Journal. I'm Steve Kendall. BGSU Center for Great Lakes and Watershed Studies moving into the fall phase of its ongoing research of Northwest Ohio's watershed. Joining us are Dr. Sarah Emery, Dr. Kevin McClooney, and Dr. Angelica Vasquez-Ortega. So thank you so much for being here today. Sarah, talk about the origins of the center, because obviously this is an important factor for the Great Lakes, Ohio, the country actually, what goes on in our watershed in the Great Lakes. So talk about the origins of the center and why it's important that we keep moving forward with this kind of research.
Right, yeah, definitely. So our center really started kind of as a grassroots effort among faculty who were interested in Lake Erie water quality, and a lot of this came about after the 2014 Toledo water crisis, where the state of Ohio started investing in improving Great Lakes and Lake Erie water quality. And so I think there was a group of faculty here that saw an opportunity to engage in more collaborative work and started forming the center. Kevin and Angelica have been a part of that center, I think, since the beginning of its formation. And what's really exciting, so I didn't join until January of this year as the director, and we've really been able to grow as a center interdisciplinarily. So we've had faculty, I think we're up to 27 faculty now in across BGSU involved in the center who are interested in Great Lakes water quality issues and really trying to connect what happens on the land with what happens in our Great Lakes. So we've been able to add faculty from English recently, computer science, history, somebody from media and communications who are all interested in environmental communication or place-based writing, or really trying to understand our role here, both as citizens and as scientists trying to make a difference with Lake Erie water.
Yeah, and Angelica, you come to us from what area of the university specifically?
So I'm a geochemist, and I do primarily soil health and water quality at the same, and I am from the School of Earth Science and Society.
Okay, yeah, because that's, again, as Sarah mentioned, this goes across the board through the university, and Kevin, the same with you. You're biological sciences, I believe, but it all ties together. So talk about your role in becoming part of the center a little bit.
Sure, yeah, I'm an ecologist, and I've been doing research at the land-water interface for many years, and one of the things I became interested in when I came here was, of course, water quality issues. And so we got involved in that in a variety of ways, looking at both sources of phosphate in the watershed and what farmers could do to change that, and then also what we could do with wetlands to change how nutrients are being processed in those wetlands going downstream.
Yeah, and Angelica, talk about what your role is and the things you've gotten involved in with the center.
Yeah, so I have been building a very robust research regarding using dredge sediments from the Toledo Harbor. So currently, every year, pretty much between November and January, the Army Corps of Engineers are in charge of dredging the Federal Navigational channels in the Maumee River and a little bit more towards the mouth, of the lake, the Western Lake Erie Basin, an area there. So the activity is every year they dredge tons of millions of dredge sediments, and then before 2020, it was allowed to put back the dredge as an open water disposal in the lake, but then because of everything that is going on with Lake Erie being sick with the algae blooms, now that has been prohibited. And we have a confined facility where all of these sediments are placed there, and the facility has a capacity or a life capacity for 10 years. So between now and 10 years, we need to find a beneficial use for that dredge material.
A better use for that material.
Yeah. If not, then we don't know where to put it, or we have to, spend more money and, enlarge the facility. So there are many different benefits, like you can use it for construction, but the benefits that we are exploring in the center is using the dredge sediment as a soil amendment. So think about most of those sediments are eroded from the top of our farm soils, so they end in the bottom of the lake. We dredge them and we put them back. Of course, we have to dewater them and then place them back in the farm, and they will be then bringing nutrients back to the farm. So it's a way of adding like an organic fertilizer without having to put synthetic fertilizer.
And at the same time, keeping it out of the lake, which is, of course, part of the problem with the things that go there. Because one of the things you would notice, and I don't know if it was just maybe not a causal effect, Wood County, of course, cleans its ditches relentlessly. It has to. And one of the things you used to see was just how much would grow along those ditches, which had to be runoff, phosphorus, all the things that were going into the soil, coming into those ditches, and then basically making everything grow really nicely along the ditches, and that meant a lot of that was going to the river. Now, when you look at this fact too, you guys are working with, Sarah, a range of other centers all over the Great Lakes and all over the country. So talk about how that all comes together as well.
Yeah, I've been really impressed with academic institutions and research centers in Ohio, and so we're part of a consortium called the LEARN Lake Erie Aquatic Research Network, which there are about 20 or so different institutions, mostly in Ohio, but also some in Michigan and some in Pennsylvania and New York, or faculty that have interest in Lake Erie water quality issues. And so there's been some really great collaborations that have come about because of this LEARN network. We have active collaborations with Lake Erie Center at the University of Toledo, with Stone Lab, which is Ohio State's research station that's on an island in Lake Erie. Also, Kent State is, Kevin could probably talk a little bit more about the H2 Ohio work. That is a collaboration of really lots of different researchers throughout Ohio trying to come together. And I've talked to the director of Ohio Sea Grant, who has said that the Lake Erie water quality problem is so big that one institution or one center can't solve that problem, right? Sure. And so it really requires a lot of different research from different directions, engagement with stakeholders, engagement with land managers, to try to address some of these huge issues.
Yeah, and I know that in talking with other folks too, the Maumee watershed, the Maumee River watershed, is the largest feeding into the lake. So that, of course, spans an incredibly large area, which means you're working with a lot of people there as well. When we come back, we can talk more in detail about what you're doing and what the future kind of holds, because obviously, as we know, this is. I remember talking to Dr. Bullerjohn. He said, this is a long-term problem. We're not going to solve it next week or in the next month or whatever. So the fact that we can start working toward a solution is incredibly important. Back in just a moment with folks from the BGSU Center for Great Lakes and Watershed Studies here on the Journal. Thank you for staying with us on the Journal. Our guests are Sarah Emery and Angelica Vasquez-Ortega and Kevin McClooney from the BGSU Center for Great Lakes and Watershed Studies. Kevin, we touched on the fact that this is a consortium of universities across the Great Lakes region, specifically Ohio. Talk about your work with Kent State, because that came up a little earlier, and the collaboration that you're working with there.
Sure. So Kent State is part of the Lake Erie Aquatic Research Network that we are also part of. And with the algal blooms, there are many strategies to try to reduce nutrients. One of them is wetlands. And so it was interesting what you mentioned earlier about ditches, because we have over 2,000 kilometers of ditches in just Wood County alone, right. Just in our county. And these are basically little mini wetlands. And wetlands are really good at trapping nutrients. The variety of different ways they can trap the nutrients. They can be sediment that falls out to the bottom and settles on the bottom that doesn't go downstream. It can be plants taking up the nutrients out of the water. It can be changes in the chemistry of the water and chemistry of the soil that can trap nutrients. And so the state of Ohio, in consequence of these algal blooms, created the H2 Ohio initiative. And that has multiple components. Some of those things are being done on agricultural fields, and Angelica can talk more about that. Right. But another component is to trap those nutrients before they enter the lake. And one of the ways to do that is wetlands. And so it's a very ambitious program to create wetlands all around the state. We have well over 150 wetland projects around the state already. And our team was brought in as part of this LEARN consortium to study the effects of the wetland restoration. How effective were these wetland restorations? Were they really good at trapping nutrients, or maybe they didn't work as well, and maybe can we find some ways to improve them? And my team in particular was focused on the plants. what is the role of plants in trapping these nutrients in these wetland ecosystems? And we're working with other people that are sampling the water and the soil and so on. So yeah, so that's sort of the consortium that has developed.
Yeah. And as we've talked about, there are all these pieces that come together and the coordination of all of that, because what happens with regard to the research you're doing, now you bring in somebody else who talks about, okay, so yeah, we're seeing this now downstream or whatever. Yeah. But you raise a good point that, because we always see that, okay, when there's a project of some sort, whether it's a road or a building project or a development project, they always talk about moving, they're going to take a wetland, they're going to restore it somewhere else. So your job, or one of the things you're looking at is, does that really work or doesn't it work, I guess is the question.
Yeah, that's a good point. You know, wetlands definitely change over time. We've seen that with these new wetland restorations. In their first few years, the vegetation changes dramatically. It's very different than when they start. And so that's really important to see how they change over time. Of course, we've also got other issues like the drought this year, and some previous years we've had drought, which, you know, the wetlands aren't as effective when there's a drought because there's not as many nutrients coming in. Of course, that's not necessarily a bad thing because there's not that many nutrients going out either in a drought. So, but in a wetter year, they might function completely differently. So we have to understand over time, we have to monitor these over time to see how they change throughout time. Yeah.
And that's the good thing is we've been on the ground now. We've been on the ground better than we have been maybe in years past because we know how important it is. And Helike, now, what you're talking about too is you're seeing the fact that those nutrients are getting into the lake and getting down there with all of the dredging and things, and then it becomes a question, as you said, of what do we do with that after a certain point in time. So what are some of the challenges with that beyond what are we going to do when we fill the 10-year tank up and now we've got to find something else to do with these?
So the main agricultural management practice that I am researching in my research group, it's using the dredge as farm soil amendments. And I have had different levels of research. For instance, I have done greenhouse experiments, and I also have done field demonstration experiments to see if what we are seeing in the greenhouse, we also can observe that at a larger scale. So far, the greenhouse experiment has been producing consistent results regarding the yield of the crops, and I have worked with corn and soybean, but also specialty crops including strawberry, lettuce, carrots. And consistently what we have been seeing is that the yields are increasing as we mix the regular typical farm soil with the dredge sediment. When we have different ratios of farm to dredge sediment, the yield of those crops is increasing. Also, the root system, it's getting more robust, and it's producing more fine roots. And then also another aspect that we are looking at is the soil health. The dredge sediment are very enriched in calcium. Their pH is slightly more alkaline, and they also are bringing nutrients like carbon, nitrogen, phosphorus. So this is a really good source of nutrients that is an alternative to synthetic fertilizers.
No.
And often, well, I was going to say, often people have questions about, whether there are heavy metals or contamination, in these dredge sediments. And Joe Fergal, who's a faculty member in chemistry, as well as Helike, you've done some work looking at kind of that question of contamination, which...
Yes, so I work closely with the soil and water conservation districts, either the Lucas one or here in Wood County, and that's a very important question that they are asking. If we use the dredge sediments, are we going to be adding heavy metals into the farmland, or are the crops going to bioaccumulate these heavy metals? So far what we have found is that the heavy metal concentration in the dredge from the Toledo Harbor are at the same concentration that our regional...
Exists in the soil in general.
It is the same concentration.
Not to undersell it, but
And some of my students have done ecological risk assessments where they actually measure using different ratios how much these heavy metals accumulated in the soil, and also how much is accumulated into the biomass that we might eat from those strawberries or the grains. Maybe animals will be feeding from those grains. And so far what we have found is that there is no preferential accumulation of the heavy metals that we have studied so far.
Yeah, and because obviously that becomes an issue when people say, oh, what are they putting on the field over there next to me? And it's good to know that, yeah, we're seeing that there isn't some sort of a concentration of things we don't want in that soil that is going to be applied and that sort of thing. Because that's sort of, I mean, not directly, but that's kind of what got us into this a little bit, is the fact that we began concentrated distribution of feeding situations from larger farms, and that then started to feed the lake, and so we're starting to recover from that. But it's good to know that we're not seeing bad things in that dredging that you're talking about.
This is the top fertile soil
Yeah.
that it's being lost by erosion.
Okay.
So we're just bringing that back. We're
bring
just
that
closing
back.
the
Restoring it,
loop.
yeah,
No?
Yeah, which I think is really exciting. Like, as a Great Lakes Watershed Center, this is really a watershed question, because it's taking soil that's eroding from fields into Lake Erie, and then we're trying to return it back to the fields to benefit farmers and water quality in general. So I think it's a great example of like the work that we can do, collaborating on watershed questions.
Yeah, and a natural way to restore it as well. We're not just, this is not just basically dumping it somewhere and saying, oh, now what do we do with it? As you said, we've got to find better ways to do it, and this is maybe one way to do it. Yeah. Well, when we come back, we can talk more, because obviously you've got a lot of other pieces going on that you guys are working on as well. Back in just a moment with the BGSU Center for Great Lakes and Watershed Studies here on The Journal. You're with us on The Journal. Our guests are from the Center for Great Lakes and Watershed Studies at Bowling Green State University, Sarah Emery, Angelica Vasquez-Ortega, and Kevin McClooney. Sarah, one of the things that's been a focus too, we talked about the Maumee Bay watershed, but Sandusky watershed, the river and the bay, there's been some activity there that's been a little unusual compared to maybe years past. So talk a little about what's going on over there right now.
Sure. So BGSU has been monitoring algal blooms in Sandusky Bay for 8 or 10 years at this point. And so we have crews that go out weekly, students and technicians on our boat in Sandusky, and do water quality monitoring, but also looking at these harmful algal blooms. And so for the first time in several years, there has been a harmful algal bloom in Sandusky Bay. That's mostly microcystis, which is similar to what is in Maumee Bay and other parts of the western basin of Lake Erie. And it's a new kind of bloom for Sandusky Bay, and we think that is probably due to changes in climate. So it's been a hot, dry summer, and so Lake Erie water temperatures have been higher than normal. Lake Erie levels are dropping, and so a shallower, warmer Lake Erie can compound some of these harmful algal blooms, even while we're still trying to control nutrients that are running into Lake Erie. And what is going on in Sandusky Bay also has many of the issues that we see in Maumee Bay, in terms of there's a huge need for dredging of shipping channels in Sandusky Bay. There they don't have a place to put the dredged materials, and so the Army Corps of Engineers is actually on hold, trying to figure out what to do to keep those shipping lanes open in Sandusky Bay. It is so shallow compared to Maumee Bay. That's a challenge that we're trying to brainstorm some solutions, or some approaches to where we could collaborate with folks who are interested in Sandusky Bay in particular, and our connection there, with our Firelands campus that's so close, right outside of Sandusky. I know there's some faculty there who are interested in water quality issues in that area too. So ideally, hopefully, we'll be able to build some collaborations with our colleagues on the Firelands campus as well.
And Angelica, I guess that's why it's so important that you are able to figure out what's going on in the river basin at Toledo, that then can hopefully then provide some solutions to Sandusky Bay, where they're looking for a solution. They don't have a storage facility, that kind of thing. As you look at that, and obviously, and you mentioned the fact the lake's getting shallower right now because of the weather conditions we're having and the temperature. How do you guys factor that in this long stream of information you have from all the years of data? How do you account for that when you're sitting down to go, okay, we've got this odd year now, what do we do with this? How do you look at that, Kevin? As you mentioned, you can't test the wetlands because they're not wet right now. So how do you deal with that then?
Yeah, that's a good point. And you know, when a wetland isn't wet, some of the plants that are in that wetland might not survive the year.
away.
You know, wetland plants need water, right? So one of the things we're doing to sort of understand that impact is controlled experiments. So we have an experiment going right now in these large 100-gallon cattle tanks, where we've put different species of plants, 12 different species of plants, and we've subjected them to different water levels. We have a drought treatment, we have sort of a typical middle water level treatment, and we have a high water level treatment. And so we can see which plants survive those conditions, so that across years, maybe you get certain species that are able to persist in the drought that can then suck up nutrients during when it's wetter, right? Yeah. And so we're trying to understand the role of those different water conditions on the wetland plants and how that influences their ability to capture nutrients. Yeah.
Yeah, we're mimicking nutrient pulses as well.
Okay. Yeah.
So I think that during the duration of the project, we have been mimicking 2 or 3 pulses, and then we see how those nutrients move through the system, you know, either the soil sequestering the nutrients or the plants by accumulating the nutrients. So we can also do that at a smaller scale and look at the soil health and the plant health. Yeah.
And we actually teamed up on this, so we've got more than one experiment. So one of the things Angelica was mentioning is, so we've got this one experiment that is really focused on water levels, and we have another experiment where we're adding dredged material to the wetlands to see if that helps their restoration. I don't know if you want to talk a little bit more about that.
Yeah, sure. So one of our hypotheses is that the nutrients that the dredge has in itself, or the organic matter content, it might be allowing better establishment of the plants and surviving better. So we are still, the experiment is still going on. We don't have results yet, but we are hoping to get a lot of results to see if that can be another beneficial use of adding dredge sediments when these wetlands are being created, so that we can add extra nutrients.
Sometimes when wetlands are created, they take away all the topsoil because they're changing the landform, and so they're removing the organic material and also nutrients, but especially the organic material. So maybe if we add some back, that stimulates the restoration.
Yeah. Now, would there be a case in this where you would find, you talked about the specific plants that might weather things better than others, would you then apply those to a wetlands restoration? These are the ones that can handle this, you know, the quote unquote sort of native plants that can deal with the extreme conditions that might occur?
Yeah, right now there's these sort of typical wetland seed mixes that they put in new wetland restorations, but they aren't really informed by either drought or nutrients that the plants take up. And so we're trying to come up with some guidance about other seed mixes that they might use to establish new wetlands. So we've got certain species of plants like broadleaf arrowhead, American water plantain, that we found can really suck up a lot of nutrients out of these wetlands. And maybe they're not in as high abundance in these seed mixes as you might want to, right? Or we also have another one like soft rush that seems to be so far handling the drought better than some of the other species, and so maybe that one is a good one to plant. It's for climate resilience. So,
and I know there are some like land managers who are actually interested in, you know, can there be a nutrient mix, like a mix for wetlands, just specifically if the goal is for nutrient management as opposed to like wildlife habitat, or, you know, some other benefits that wetlands can provide. But because of the funding through H2 Ohio, a lot of these wetland restoration and creation projects, their priority is nutrient management, and we don't necessarily have a great recommendation for like what they should plant specifically for nutrient management.
Yeah. Now, do you find that what goes on here can be translatable to another location in the state, or is there a lot of uniqueness there? Because I know that when Dr. Boulajan would go to Lake Victoria, it's like, you know, there were a lot of similarities, and that's of course around the world somewhere. So do you see that be able to apply this maybe more than just here in Northwest Ohio eventually?
Yeah, that's a great question. So first of all, wetland plants are unique in that they can survive these inundated conditions. And so just because of that, there is a lot of similarities between wetland plants all over the world. But another thing we're trying to do is, rather than the species specifically, look at the traits that are associated with the nutrient capture. Like what's the amount of root material they make relative to their stems above ground? What is the relationship of the size of their leaves to the weight of the leaves is actually a trait that could be applied to a different species on the other side of the world, right? And so we can figure out which traits of the plants are most beneficial, and then it could be applied everywhere.
Yeah. Okay. Now, real quick, we've got like about a minute. Sarah, what's the next thing you guys are looking at? Maybe a new add-on to what you're doing currently? Is there something that you're looking at in the future to add to the center in terms of the next research project or not?
One of the things that we're really interested in expanding the wetlands work is trying to bring in some environmental historians who know a lot about land use, previous land use, using land use records from like the early 1800s to say, you know, what was growing here in the wetlands before it was converted to so much agriculture, and can we learn something from like the history of what was here to build better wetlands, basically. And so we're kind of bouncing around some ideas about projects that could include sort of this historical perspective on wetland creation and function.
Good. Well, Sarah Emery and Elika Tegastega and Kevin McClooney, thank you so much for being here with us today. And of course, anytime you want to come back and talk about this, obviously such an important topic for living here, the quality of life, and the economy of Northwest Ohio. So it's important that we solve all of these problems, like the dredging, like the wetlands, and get our arms around all this and get it, and hopefully get it taken care of in the next couple of months. I'm just not going to happen, I know. Hopefully sooner rather than later, I guess we're going to go with. So thank you so much for being here. You can check us out at WBGU.org. You can watch us every Thursday night at 8 o'clock on WBGU PBS. We'll see you again next time. Good night and good luck.